So we're kind of doing synthetic division here on number 1. Do you guys recall? We're dividing p of x, which is 3x cubed, 3, 7, negative 2, 6. I forgot already. 3, 7, negative 2, 6. We're dividing by x minus 1. And the question is just what's the remainder? That's all they're asking. So basically we have to do division. But we're kind of leading up to something else, so you guys do need to do synthetic to do this new stuff. So you guys remember how it goes? What goes in the box? Positive 1. So you always do the opposite of what your divisor is. So put positive 1. And then you take the coefficients down, right? So 3, 7, negative 2, 6. Draw a line. You guys remember how this goes? Some of you did long division, so you might not have got this down yet. 3 plus nothing is 3. And then you do this number times this number and put it there. So 3 times 1 is 3. And then start over, add down. 7 plus 3, 10. Multiply up, 10 times 1, 10. Negative 2 plus 10, 8 times 1, 6 plus 8. Okay, so the answer, the remainder would be 14. If we were doing a whole division problem, this stands for the number, the x term, the x squared term, so it'd be like 3x squared. You don't need to write this down, but I just want to remind. And this would be the remainder out here. But all we have to do is put the negative 14 part. Do show your work. Okay, it's not something you do in your head. Okay, number 3. What do I put in the box on number 3? We're dividing by x plus 2, so what am I going to put in the box? Negative 2. Using the same p of x, so I'm going to use the same coefficient, 3, 7, negative 2, 6. Okay, add down, 3 plus nothing, multiply up. 3 times negative 2. Add down. Adding negative 6 is like subtracting, so it's 1. Multiply up. 1 times negative 2. Negative 2 plus negative 2. Negative 4 times negative 2. On your calculator, I don't know if you guys figured this out, but you can just start right here, do like 3 times negative 2. Write that down there, and then put plus 7 equals times negative 2 equals plus negative 2 times negative 2 plus 6. You can kind of do it quickly. Anyway, just coincidentally, it happens to be 14 again.
Is it a coincidence?
It is a coincidence, yeah. There's no, it could be any remainder. By the way, number 2, if somebody's tried it already, is bigger. It should be bigger than 100, so don't freak out. So they can get large quickly. Okay, number 5. Use the factor theorem. You don't need to know what that is. To determine whether each binomial is a factor. How can we tell if something is a factor or not? Is 3 a factor of 106, for example? How could I tell? Huh? You divide, and then how can you tell if it's a factor? If I asked you, is 3 a factor of 106, how would you figure it out? You guys know what a factor is? Maybe we should back up a step. What's a factor? It's something that multiplies into something else. So if you divide and then what? Okay, if you divide and there's no, is 3 a factor of 16? Let me make it smaller. Is 3 a factor of 16? No, how'd you know? Because if you divide it, there's a remainder. It doesn't divide evenly. So 3 is not a factor of 16 because the remainder is 0. 3 is a factor of 15 because the remainder is 0. The remainder here is 1.
So if we get 0.
If it divides perfectly, yes, it's a factor. It's something that multiplies into it. So basically what they're asking on 5 through 8, if we divide, is there a remainder? If there is a remainder, we're going to put no, it's not because it's not a factor. If there is a 0 remainder, if there's no remainder over here, we're going to put yes because it is a factor. So for example on 3, if they were asking us, is x plus 2 a factor of this thing? The answer would have been no because there was a remainder, besides 0. So we're just figuring out if there's a remainder or not. So half of these, by the way, will be like yes, half will be no. So it should be like 50-50. One odd, one even. Yes. Okay, so dividing again. X minus 2, so what am I going to put in the box? So I'm going to divide my x minus 2. 2. And the coefficients for 5 are 1, negative 10, 17. It's kind of a large, getting larger. 52, negative 60. Okay, I'm going to go a little bit faster. Add down 1 plus nothing is 1 times 2. Negative 10 plus 2 times 2. 17 minus 16 times 2. Add down times 2. Doesn't really matter what the remainder is on this one. As long as it's not 0, I'm going to put, you guys know what I'm going to put? No. Because it didn't divide evenly, basically. It's not a factor. This time it's x plus 2 as the divisor, so I'm going to put negative 2 in the box. And we're using the same coefficients. Come on now. Add down, multiply up. Add down. Multiply up times negative 2, add to 52 times negative 2 plus negative 60. Okay, so I got 0 for the remainder, which means it divided evenly. So I'm going to put yes because it is a factor. Number 9. Okay, this is 9 is actually new. So 1 through 8 we kind of redid synthetic, but number 9 is new stuff. So let me copy this down before I get rolling here. 1, 5, negative 2, 6. Okay, so the directions on number 9 says, if you're doing an even, you need to stop and listen. Use the rational root theorem, I'm about to explain what that is, to find the possible rational zeros for each polynomial function. Do you guys remember, like last Thursday, what's a zero of a function? What does that mean? It's on the graph, it's the x-intercept, but it means What x values makes this whole function equal 0? That's the 0 of the function. What x values, what could I plug in for x that would make all of this equal 0? Well, no, if I plugged in 0, I would get like 6. So 0 is not a 0 of the function, if that makes sense. Confusing. I don't know if there is a good answer for this one. Sometimes there are no real zeros. This one actually should have 1. Okay, anyway, let's focus here. So, last chapter, we solved like quadratic equations with factoring or quadratic formula. Why can't I use that here? What's wrong with this one? Yeah, it's not a quadratic equation. Quadratic means x squared. It's called a cubic function because it goes up to x cubed. So the factoring tricks we learned, the quadratic formula we learned, that's not going to work on this one. So there is a trick. This doesn't solve it, but it gives us some possible answers. It's called the rational root theorem. Now, I said the values for x that will solve this, that will make this equal to 0, are called the zeros of the function. They're also called the roots of the function. So it's a synonym. It means the same thing. Zeros of the function, the roots of the function, are the values for x in which the function equals 0. The possible rational roots. Rational means like fraction, like normal, or could be a whole number or integer. Rationals are like normal answers, not square root answers. If there are normal answers for this, here's what they could be. Okay, you take the last coefficient, the constant, 6, put it on top, and then you take the first coefficient, which is what? 1, and you put it on bottom. Okay, the possible answers are factors of 6 over factors of 1. What are the factors of 6? 2, 3, 1, and 6. So I'll put them, the order doesn't really matter, but I'll just write it in order. Those are possible, those are factors of 6. What are factors of 1? Just 1. That's good news. Okay, so the possible rational roots are 1 over 1, which is 2 over 1, 2, 3 over 1, and 6 over 1. 6. So 1, 2, 3, and 6 are possible. However, factors of 6 are not only like 1, 2, 3, and 6. Could be like -2 times -3, right? Could be negatives. So all of these could be positive or negative. But these are the possible answers. If there are any normal answers, these are possibilities. Something else that is new. Remember last chapter when we were solving these problems, how many answers did we typically have when we solved these? Two, right? Like in this case it'd be like -4 and 1. Well, unless sometimes something weird happened, like it was like x plus 4, x plus 4. In that case, you'd only have one answer. It's called a double root, but it's like a double answer. But typically, there were 2 answers, right? So that's because it's a quadratic equation. But what if it's like a cubic equation? Well, how many answers do you think that should normally have? 3, normally. It could be, you could have a double answer again, or a triple, even something called a triple root. So you could have less, but normally you should have 3 answers. You could find out if these are answers by just plugging them in, by the way. Like plug 1 in, does that make it equal to 0? I think the answer would be no. 1 plus 5 minus 2. Yeah, it doesn't work. But you could check. We don't have to check on these though, I'm kind of getting ahead. This is what we have to do in the B section, is actually find the answer. I'm kind of getting ahead of myself, but you can just stop right there. Number 9 and 11 and these. Alright, let's see if you guys remember what I did. Let's start over. Number 11, that's really short. It just says P of x equals x cubed plus 8. Alright, so you remember what I did? I put last number, last coefficient 8, over the first coefficient to 1 again. It's not always going to be a 1. Number 12 is not a 1 on the front. Okay, what are the factors of 8? And what are the factors of, what is the factor of 1? So the possible answers are 1 over 1, 2 over 1, 4 over 1, 8 over 1. In other words, 1, 2, 4, and 8. Plus or minus. Don't forget that part, or I'll be mean and take half off. You got a bead blower chair. A bead. Can you toss that to me? Plus more.
You need it? Didn't need it? Can you be quiet?
Just,
Look at how long her vein
you just
was.
lost 10 points. And there goes all your Mario bonus. One shot. Take it away, Mario. Okay, let's look at 12, because, yeah, I'm afraid the number on front will freak you guys out, so let's look at it. So 12 starts with a 4, 4, negative 5, 3, 7. Okay, so what am I going to look at? Factors of 7 over factors of 4. What are the factors of 7? What are the factors of 4? Okay, so by the way, does it matter if this is like a negative out here? Well, factors of negative 7 could be positive 1, negative 1, positive 7, negative 7. So no, it doesn't matter at all. So it's 1 over 1 or 7 over 1. Or 1 over 2, 7 over 2. So fractions. If the fraction reduces, you need to reduce it, by the way, just like always. Or 1 over 4, 7 over 4. You guys follow that? So that's all I want on that section, just that part. You don't actually have to figure out what the answers are. Number 13. Okay, evaluate f of a by synthetically dividing by x of a. Okay, some books call this synthetic substitution. We're not actually dividing, really. So what they want us to do on 13 is find f of 3. What does f of 3 mean? Yeah, it means you plug in 3 for the x value in the function and just see what it equals. Which you could do that normally and get it right, but you can also do it with the synthetic method that we learned for division. And we kind of need to practice this for the B section, so I want you guys to do this synthetically. 4, negative 10, negative 26, 60. Okay. 4, negative 10, negative 26, 60. Okay. So, here, I'll just write it. The old way to do it was we just put in 3 for the x's and then just saw what came out. You can do this synthetically, and the number that comes out at the end would be the same thing as doing it the old way, like where the remainder is. Now, we're not dividing this time. We're not doing division, really. So the number that we're going to put in the box is not going to be the opposite thing. So it's just going to be 3. Okay, but yeah, it works the same as division. So add down, multiply up, add down, multiply up, add down, multiply up, add down. Okay, it's not going to come out as 0 normally. It's just a coincidence. That does tell me, though, by the way, that 3 is a 0 of this function because it made the function equal 0. But the answer is 0. So if I plugged in 3 up here, like we, if I use my calculator or whatever and plugged all that in, I should expect to get a 0. Whoops, a 0 right there. Okay, that's what this means. When the x value is 3, the function is going to equal 0. Okay. $15, same thing. So I'm going to put 1/2 in the box. Fractions, time to panic. If you have not been panicking up to this point, it's time to begin. Just kidding, it's fine. Something is weird on 15 though. Can you guys identify anything weird about 15? Let's drag this down. Yeah, it skips an x cubed function. Remember when we talked about this on division? Yeah, you need a placeholder because it goes from 4x to the 4th to jumps over x cubed to minus 5x squared. So we're missing like an x cubed term, and we do need a placeholder for that. So we need to throw a 0 in. I don't think they put that trick on the evens, I don't believe. But we do need to know that for later. So it's actually 4, 0, negative 5. 4, 0, negative 5. And what? Negative 2, 9. Okay, add down, multiply 4 times 1/2, 1/2 of 4, 2, add down, 1/2 of 2, add down, 1/2 of negative 4, negative 2 plus negative 2, 1/2 of negative 4, so that one comes out as 7. Well, okay, I think here's what I'm going to do. We'll do some more on this tomorrow, but I do want to look at 17 just so you'll have seen it once. That way you'll freak out less tomorrow. Because it's kind of a lot to take in, so if we do it a few times, it'll get in your brain better, I think. Let's scroll up a little bit. You can try 18 if you want to, I guess. But we'll work on it tomorrow. I don't think I'm going to follow the directions exactly for this section because we're kind of trying to do a little too much right here. But okay, I'm just going to say, they said factor this using the theorems that we use, figure out the factors for this. I just want to find the zeros of the function, which is almost the same thing. So in other words, solve this for what x values make this equal to 0. That's my goal. Okay, we're going to start with the rational root theorem, which means what are possible answers for this function, for the zeros of this function. So I'm going to start with this. Factors of 8 over factors of 1. These are my possible answers. This time, however, I'm going to actually figure out which answers work. So factors of 8, we kind of already did this one, are 1, 2, 4, and 8. Factors of 1 are 1. So my possible answers are 1, 2, 4, and 8. Positive and negative. It's kind of a lot. Okay, how can I tell whether these are actual answers or not? Plug them in. Now, you can plug them in the old-fashioned way, just put it in there, or you can use synthetic. There's kind of a reason we want to use synthetic, but I'm going to start with plugging in the old way. If I plug in a 1, it's kind of easy. What's 1 cubed? 1. 1 squared is 1, so that would be stay minus 5. 2 times 1 is still 2, and 8. Okay, does that equal 0? No, I don't think it does. So I'm going to try negative 1. Hopefully that one works. Kind of trial and error. So, does that one work? Yes, it does. Okay. So I know negative 1 is supposed to work. I'm going to go ahead and use it, kind of show it works again using synthetic substitution. There's a reason you kind of need to do this.
So we're putting the two together?
Kind of combining, 3 different things, yes, to solve this. Okay, I know that negative 1 is a solution. Remember I said there's normally there will be 3 solutions for this. If it's a cube. No, because when you square negative 1, it becomes a positive 1 times negative 5. Okay, so add down, multiply up. Now, if I did it right, this should equal 0, right? Because I know negative 1's, I think negative 1's supposed to make it equal 0 from what I did earlier. So multiply by negative 1. And yeah, I got it equal to 0. So negative 1 is an answer. So we'll just kind of keep that in our back pocket. But should be 2 answers remaining. Should be 3 altogether. How can I find the last 2? Well, here's where it gets a little bit hard to explain. Remember how when we factored like this, I did one of these earlier, and like if these are the factors, like negative 4 is an answer and positive 1 is an answer. Okay, if negative 1 is an answer, that tells me that x plus 1 is a factor. And if I also know if I divide this by x plus 1, I should get this, because I put like a negative 1 in the box right here. I should get this. So my remaining 2 answers are kind of hidden inside here. There's like 2 more factors that have the 2 remaining answers. Like I know negative 1's an answer, so it's like I divided that answer out already. I took the answer out from this. And the remainder stuff, this leftover stuff down here, kind of contains my last 2 answers. So, but the good news is now that it's only an x squared problem, I can use factoring or quadratic formula. Yeah, so this kind of goes back to the last chapter. So the last 2 answers are 4 and 2. So all 3 together would be negative 1, 4 and 2. Now notice 4 and 2, they were in my list up here of possible answers. I just never plugged them in.
So you won't also put like x equals
Yeah. So what the book wrote instead of this, solutions, they wrote it in factored form, which is like this. And that's to me that kind of feels like an extra step. It's a little bit, I think we should just stop right there. But anyway, if that stressed you out, don't worry about it. We'll focus on it tomorrow. We'll get it down. But just try to get at least to 16. 16. Just do the easier part for today. You want to try feeling bold, you can try 18.